Okay, today we are going to solve two questions. And if I remember correctly, we solved a few during the lecture hours. And if you need more, you can let me know, and I would record a few more videos if you want. But after the tutorial session, immediately would release the solution for these questions, because you need to know for this week and next week. Okay, we are going to start with question 5. We have a tank for the water, a pressure gauge is attached to a specific height, and manometer, but this is inverse manometer instead of usual, with some liquid which is lighter than water because it's 0.8, and attached to this bead, can't be anything, pipe. And the question says, find pressure at pipe B. So find pressure here. And then, yeah, that's it. Let's solve part A. Very easy. Start with simplifying. We don't care about the geometry like the tank. All can be a pipe. Convert the pipe to the tank to the pipe. So when you go up, subtract. When you go down, add the pressure OTH, and there are some points you need to jump. You know, same height, same liquid, jump. Okay, start solving. I'm going to come and check how you did. Giving you 5-6 minutes to investigate this question. Morning. Could you please sign as this? Rho G and rho G is
That's what that's why.
for the water 9.8 1 times 1000 is this for the water and G is 9. You need to practice it because basics is very easy. Just you need to use rho GH, but you need to practice enough to see where to start writing the question. For example, for this question, you need to start from somewhere which is the easiest. That PA point A is the easiest because you have actually the pressure. Start from there. If you start from C, you don't know. That's the secret. I will show you that. For now, just find pressure at point B.
1 and 1, 3, 2, 5, 2, 7, 6. Perhaps.
Good. You're doing good. Correct. This is the most important part. It should be just right. So PA is okay right now. Okay. Now you need to go down, but same height jump. Same height jump. Back, what? Doesn't. Okay, you mean the same? Okay. What's the formula for specific gravity? Rho divided by rho for the water. So rho we don't know, but rho for the water is 1,000. 1,000 times that is going to be
So 1 and 1, 3, 2, 5.
so it's something.
So
It's something.
yes, 1 times.
So density of that there is going to be 8 times now you can use that density plus the formula rho G H. If you could, just don't confuse yourself. Yeah. What is this? 8. Oh, 3. if I push you, you don't have any choice to go back. That's it. We always go back. Gauge push. Wait a minute. Okay. Yeah, practice. Okay, yeah. You need help with something. Simplify this as a pipe. Because we don't have got that. So EA plus equal yeah, because EA plus this equals yeah, that's good. Great. Great plus okay. Simplify. This can be applied. So same liquid, same jump.
Yeah. Yeah.
Okay. Okay, correct. And this is going to be equal to correct?
Yeah.
Same.
Oh. Sorry.
Yeah, it's good. What can I say? Good. Did you just? I always know that. Okay, 60. Because you're right. So okay, yes. This is PA. This side plus the delta equals delta. So rho for the liquid is G H is 3 plus this side rho for water and G times H which is 2 this must be 3. No, this is 6. 6 basically just change the way you write it from the way it's covered in your mark. Okay. Any question? Okay, let me solve and give you a bit more details. Okay, this is our drawing. Let's simplify it, and I'm going to use black. So let's first find the important heights. And this height. So, and this one. So I'm going to have from point C, the pipe is going to down like this. This is closed. Up to the highest level here. Okay, so let's color water section. So water is going to start from here, hold this area, and that liquid, let's go with green, is going to be up to this level. Great. And the rest again it's water. Done. This is point A, this is C, and here it's B. So I'm going to start from point A because I have the pressure, so why not start? If I start from C, nothing there, so I don't know. So pressure at point A, I'm going to start here. Same liquid, same height, I'm going to jump to point 1. Same liquid, same height, jump to point 2. Now from 2, I'm going downward. So add plus the green, which is going to be density for green color, times G, times the height, which is 3 meters. Plus, now I reached to this point, which is point 3. Again, downward, I'm going to add plus density for the water times G times height, which is 2 meters. That is going to be equal pressure at point B. Okay, we have a specific gravity, and let me write the formula. Specific gravity is density divided by density of water at 4 degrees. So this is given, it's 0.8 density of green liquid divided by, let's go with 1000 to make everything easy. So density of green liquid is going to be 800 kilogram per meter cube. So plug the numbers. 60 times 10 power 3 plus 800 times 9.81 times 3 plus 1000 times 9.81 times 2 must be pressure at B. Pressure at B is going to be 103, if I don't make a mistake, kilopascal. Any question about this part? Again, let me repeat. If you feel you have a trouble with this chapter, learn it this week. Don't let it for later, it will be big trouble. Okay. The second part says the pressure head in millimeters of mercury at the top of dome, which is point C. So find pressure at point C, but in terms of millimeter of mercury. So the first step is going to be just find pressure at point C, which is really easy. Yeah, before that technology, 50 years ago. Or if you practice, if you don't practice very well, we're going to put you there. Just okay, you have to write the question. Yeah. We know pressure at this level. Now try to connect this to the this is pressure. How many millimeters of mercury is going to generate that pressure? That's what. Okay. Very good. We had successful performance for this one. Okay, so for pressure at point C, the easiest way is going to be start from point A, go up, down. So I'm going to do the same. So pressure at point A, I'm going upward. So if I zoom it here, from point A, I'm going upward, so I'm going to subtract till point C. So let's do that. Point A minus gamma for water times that height, which is 3 millimeters. We don't care the geometry. That can be any shape. This is hemisphere, it can be any shape, but for us it's a 3 meters pipe. Must be equal pressure at point C. So pressure at point C is going to be 60 times 1000 minus 9.81 times 1000 times 3. So PC is going to be about 30.6 times 10 power 30.6 kilopascal. Okay, now I want to convert this to the height of mercury. So as Shikar says, basically you are going to see I have a pressure, and this is the formula, rho GH. So if I want to write it in terms of mercury, I can say rho for mercury, height for mercury. So let's plug the numbers. So I have this 30.6 times 10 power 3 pressure, then the mercury would be 13.6. So 13.6 times 1000, it's going to be density for mercury times 9.81 why I'm writing like this. Go out. Okay. Times h for mercury. So the height, if I use mercury, is going to be almost about 230 millimeter. So if I ask you write down in terms of gasoline, if I give you the density or specific, you just say, okay, the density of the gasoline, density of oil, whatever pressure you give me, just convert to that. Okay. So now the warm-up is finished. Let's have one question similar to the final exam question. This is 3.5 kilopascal. This Z is 0.03 meters, and this B is 13.6. This A is 0.6. Okay, now I gave you all the unknowns. This A is 0.6, B is, so mercury 13.6. The pressure at the air side is given. Some liquid we have here, mercury there, and it's open. Find H. Same steps. Simplify it. Write down pressure balance. The only unknown is going to be H. See, you think you know, but there's always one question challenge you. Get rid of all the tanks, convert all to tubes. And all those tubes must be connected. Vertical or horizontal tubes. That's it. And start from air side.
What if we find
Hmm? Yeah, the only unknown is H, so we can. If you write the pressure balance after simplifying, you will just H unknown. Simplify it, otherwise you make mistake. open is only always use gauge except if I push you to use, otherwise just use gauge. Let's see what that was. You're good. Okay, that's good. Okay, that's good. So I'm gonna take this. Everyone's needs. Good method. Very absolutely. Jen, good method. Actually, I should teach later for next year students to draw that line. One point for the air we already talked. If the height difference is very small, like this, we don't care pressure here, 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 and here, same. So that 3.5 kilopascal is there. It's a good point. And Jenna did something really interesting. She drew a line and just horizontal and vertical to connect these tubes and just follow that line. It will be a good solution actually. It was nice. Inside one liquid, have just one horizontal line. If you have two horizontal lines, so one of them is unnecessary. This question is the hardest type of question for this pressure reading I can give you. For the final, for the quiz, definitely it's going to be a little bit easier than this. it's a good habit to have some bottle to drink water. I used to not drink the whole day, just forget about it. And then I found I had like a kidney stone. Then I said, okay, the pain is so bad. Have something to drink because that kidney stone is really, really, really painful. By the way, H is 1.9 meter if you got similar or close to that. Okay, now focus here. Let's see how I'm going to investigate, and then you try to imitate for future questions. Okay, for the air part, as we discussed, pressure everywhere is going to same. So I don't need to have the whole tank here. So I'm going to draw that gauge here. So because pressure here is going to be same, so I simplify it and get rid of this pressure. Now let's use Jena method. We are going to call it Jena method. So this part is okay. Let's go down, horizontal, up. I'm going to vertical go inside this liquid, the orange one. And I need to reach to the other pipe, so I'm going to horizontal, come down, this one and this one. Okay, problem. I have two horizontal lines here. We don't need. So I'm going to get rid of this one and this one. So directly go down. And the rest would be easy, done. So let's redraw the whole then simplified version. Okay. So I'm going to have that gauge here. Then let's go downward up to this stage. Should I go even lower up to this level? Yeah, why not? If I go like this, same liquid, same height, I'm going to get rid of it, so it doesn't matter. So if I want to simplify even further, I can go even further down. It doesn't matter. I'm not doing very well here. Okay. Now let's go up to this level for the water to go inside the orange. Now this part again, the upper part is my choice because again I'm going to get rid of it. So let's go a little bit further, for example here. Now I'm going down up to this level, which is here. And from here again I can go down and this level, which is here. This Z level, and yet after that it's 0, so I don't care. So let's color it. Mercury is dark blue, so let's go with dark blue here. Dark blue for Mercury. And orangish for that liquid up to this level. So the rest is going to be water and air. So I'm going to use this bluish as a water level. Starts from here up to there. Great. And let's identify where is H. H is going to be from here to here. Yes. Okay, correct. What else? Let's identify other heights. So from orange to the other side, so here I'm going to have .03 meter. What else? Yeah, this is the only thing we need because they are all jumping points. Okay, let's start writing. Okay, before we start writing the pressure balance, let's take care of the specific gravities. So specific gravity for that liquid, which is 0.6, is going to be equal density of that liquid divided by density of water. Therefore, density of that unknown liquid is going to be 600 kilogram per meter cube. For the other one, mercury, Hg, the density is 13.6. Density of Hg divided by density of water, therefore density of mercury is going to be 13.6 times 10 power 3 kilogram per meter cube. So I took care of it. We don't need to additionally add SG in our all calculations. So pressure for the gas G, what color? Let's go with red. So I'm here, 0.1, which is pressure of the gas at the surface of the water. From there, same liquid, same height, I'm going to jump. So same liquid, same height, jump to this point, which is 0.2. Now from 0.2, I'm going upward, where up to this level, which is going to be 0.3. So upward minus, it is going to be negative. What is the height? H. H times rho g. Rho g for the water. Later I'm going to add. We use H2O. Okay. From 0.3, again same liquid, same height. Let's jump to this point, 0.4. From 0.4 downward up to this level, 0.5. So it's downward, so I'm going to add. Again H. The height is H. And what is the liquid? Liquid is that liquid. Gamma for that liquid, L. From 0.5, I'm going to again downward to this level, which is, let's call it 0.6. It is downward, so I'm going to again add. What is the liquid? It's dark blue. Dark blue is mercury. So gamma for mercury times the height, which is 0.03 given. And from 0.6, let me zoom a little bit more. From 0.6, again same height, same liquid, I'm going to jump this side, 0.7. This is 0, so surface outside. Gauge pressure is going to be 0. So 0. Let's plug the numbers and factor H. If I factor H, I'm going to have gamma for water minus gamma for that liquid is going to be equal pressure for the gas plus 0.03 gamma for mercury. Therefore H is going to be Pg plus 0.03 gamma for mercury divided by gamma for water minus gamma for L. Just now plug the numbers. What is Pg? 3.5. So 3.5 times 10 power 3 plus 0.03 times 13.6 times 10 power 3 times 9.81 divided by 1000 for water times 9.81 minus 600 times 9.81. Therefore H is going to be 1.9 meter. Any question? Thank you very much. See you in the afternoon.